In other videos, we've talked about a couple theorems about rational roots. Now let's talk a little bit about irrational roots or even imaginary roots. The conjugate root theorem says that any irrational roots always occur in conjugate pairs, as well as any imaginary roots also always occur in conjugate pairs. If you think about using the quadratic formula and where you get these the irrational numbers and the imaginary numbers from, that part of the formula, those come from the square root part there, and then right in front of that, in the quadratic formula, you see the plus or minus symbol. So I think this is a good place to make a connection to that, is why they occur in conjugate pairs. So what this means is that if you're told that something is a root of the function of an equation, like let's say that the square root of 2 was a known root of the equation, or let's say that 2 minus the square root of 5 is a known root of an equation, or maybe 3i is a known root of the equation, or maybe something like 2 plus 3i square root of, I don't know, 5, something like that. Maybe that's a known root of your equation. If that's the case, then the conjugates of these must also be roots. So if they tell you the square root of 2 is a root, then so is negative square root of 2. If they tell you that 2 minus the square root of 5 is a root, so is 2 plus the square root of 5. That's the conjugate pair with that. If they tell you that 3i is an imaginary root, then so is negative 3i. That's its conjugate pair. If they tell you that 2 plus 3i square root of 5 is a root, then so is 2 minus 3i square root of 5. Again, the conjugate root theorem saying that any root that we have that is irrational or any root that we have is imaginary, they must occur in conjugate pairs. So if they tell you one of them is a root, you must have enough insight to know that the other one is also a root of this equation.